Hello and good evening. Welcome to another Monday night Q&A session. I hope you're all safe and well and have recovered a bit perhaps from events at the weekend. I'm joined tonight by one of my colleagues from the Technical Helpline group, Mark Barnes-Ryder. Good evening, Mark.
Good evening, Sam.
How are you on this warm, muggy evening?
You're not too bad. A little bit deflated from our result of yesterday's match, but despite that, I think we still did very, very well to make it through to the final and give the performance we did, to be honest. So I think all credit to Gareth Southgate really on that one.
Yeah, definitely, and it was a great tournament, great few weeks of football, some great football, and I think it's just the age-old thing that we slowly over the 3 weeks raised our expectations and maybe we raised them just a little bit too high. But because like I think we said, if you'd have said England are going to get into the final at the start of the tournament, you'd have took that. So yeah, very good. Okay, well, without any further ado, we'll quickly flash up the question of the week. So this week's question of the week was, what's the current carrying capacity of 2.5mm squared twin and earth cable when it's covered in more than 100mm of thermal insulation? So I guess a typical or perhaps a bit overzealous loft insulator, whacking a couple of sheets of loft insulation, and we could quite easily then get over 100mm, over 10 centimeters of thermal insulation sitting on top of our 2.5mm twin and earth cable for the upstairs ring. So what can you tell us, Mark? What should be the current carrying capacity of that situation when we've got the cable covered by thermal insulation?
Sure, yeah. So I mean, there is a table in BS 7671 that refers for those reference methods that are involved with thermal insulation. So they're our method 100s to sort of 103. Table, as you said there, table 4D5, and that's for 70-degree thermoplastic cables. So typically our twin and earth sheath flat cables. We're looking at methods in the description. We're looking at method 101. So for we are looking at method 101 in this example. That says 2.5mm cable can handle 17 amps. Yeah. Because it's restricted by the 100mm of thermal insulation.
So it's just exceeding. We'll just show the audience that table. So as Mark says, that's table 4D5 in Appendix 4, and then we're reading across for the size of the conductor 2.5mm and coming down the column that's associated with that type of installation method. So it would be 101 in this instance. So yeah, brings the current carrying capacity down to 17 amps. We can see that if we use the example of if there were no thermal insulation and we were treating the same cable as clipped direct, it would have a 27 amp current carrying capacity. So quite a drop. We're dropping 10 amps in 27, so that's over a third of the current carrying capacity is lost due to that installation method of covering in more than 100mm of thermal insulation. So big detrimental effect to the current carrying capacity. And I think then that follows on then with the follow-up is what kind of effect does that have on our ring, and where can we get guidance on the required current carrying capacity for 2.5mm when it's in a ring final installation?
So that takes us nicely into regulation 433.1. 1.204, it actually tells us in that reg, if you're using certain types of standard devices for 2.5 cable, that the cable needs to carry 20 amps in any leg of the circuit for it to comply for a ring final circuit, so that you've got adequate coordination between the protective device and the cable.
It's because it's worth pointing out that we definitely, when we're looking at the 2.5mm cable, we saw from that table that it will only carry, or it's rated at carrying 27 amp under clip direct conditions. So we know that the 32 amp protective device isn't providing overload protection. But when we've got it in a ring configuration, we're assuming that 32 amps is split down each leg of the ring, each side of the ring. And so because it's in that ring configuration, it will never have to carry the whole current from a particular load back to the source in the board. But we need to ensure, if we're using standard ring configuration with standard ring accessories, that we should have no less than 20 amp current carrying capacity. So our loft insulation example we'd have to consider derating the overcurrent protective device, and obviously that's going to give us reduced capacity on that ring. So can have a big importance, big detrimental effect. So we'll just quickly show them that reg. I do apologise, I appreciate it's very fine print, but as Mark said, you can have a look at it yourself, reg 433.1.204, and it's in there where it talks about ring final circuits. Such circuits are deemed to meet the requirements of the regulation associated with protection against overload current if the current carrying capacity of the cable is not less than 20 amp. So when we're in that situation down to 7, we're actually not complying with that reg, and we could potentially be in a situation where we might overload that cable depending upon how heavy the load is on the ring itself. Okay, we've got to have a look at a few hangover questions from last week, Mark. So the first one was associated with when changing a consumer unit in a cupboard shared with a gas meter, and you can't get the required separation, what's best to use as a separator? So yeah, there's some guidance on minimum distances, isn't there? But what happens if we can't achieve that minimum distance, I guess due to restrictions within the cupboard itself?
Well, you might need to think about putting some form of insulating material over the pipework. It needs to be insulated to a minimum of 230 volts, because that's what our system will, if we're talking typically domestic, that's what it will work on. Maybe greater than 230 if we're talking a commercial or industrial type installation, but nevertheless, you'd need to insulate that exposed conductive part or extraneous conductive part, or you can put a physical barrier between the cabling and the pipework, a sort of an insulated non-conductor, if you like. And typically out on the market you've got Paxilin. You can get that in various sizes and various thicknesses, typically 5mm thick, but that normally does quite a good job. But we tend to use it between as an insulator between sort of class 1 fuse boards and galv trunking, things like that, if you're trying to create a non-conductive spacer. So the low pressure pipework regs you talk about, Sam, is that quite rightly BS6891, and there is mention of it in page 24 of the on-site guide. So folks can you can go to that page, and there'll be a little bit of information in the on-site guide on that.
Yeah, but it's perhaps the most important thing is we're trying to provide a means of electrical insulation. So we want to insulate the conductive parts, the pipe work associated with the gas, the metering, the gas service equipment itself, from any potential electric shock, any electric voltage potential transfer. So yeah, we're looking at insulating material. So yeah, either around the gas pipe work itself, or as you say, a physical barrier between the two. Another one, this was one where perhaps we briefly talked about this, and we said this would be a question that we would ask lots of questions about it, but we'll read it as it was put into the chat room last week. The engineer involved said they had a recent EICR with a PV install which ran through the bungalow loft. The protection was via a B-type RCBO, and the engineer believed it should be double pole if required, but the cable run does not require an RCD. So they were asking about coding for with respect to an EICR. But yeah, so that was the concern was raised that it had an RCBO protective device, and the engineer believed it should be double pole. That was his concern. So what are our thoughts on that one, Mark?
I mean, there's a fair bit to consider there, isn't there, in any, before you issue any sort of code on a condition report. And with this system, I mean, if it's grid connected, then there's generally a requirement to offer to install double pole isolation, depending on the size of the system that will come under, one of two sort of engineering recommendations. If the RCBO is just providing overcurrent, then there's no specific requirement to provide double pole. I mean, the RCBO wouldn't be suitable for isolation under those conditions if double pole was required. Consideration would also need to be given to the users of the installation. So, for example, if it's being used by skilled and instructed persons, there may well be a different requirement regarding providing that isolation versus a non-instructed person that will perhaps need a double pole isolation, for example. Yeah.
So I think it's one of those ones if we had the question on the phone, we'd ask a few more questions, because it could be that if we have got a double pole means of isolation on the AC side of the inverter, then having an RCBO to provide overcurrent protection is perfectly compliant and no issues at all. It would only be where there isn't an independent double pole isolator that we'd take issue with the overcurrent protective device, not for not being an overcurrent protective device, but for not being able to provide isolation for both line and neutral. But as Mark said right at the beginning, that's only a requirement if it's a grid system. So if we were talking about an off-grid system where the PV was being used to charge batteries, or just internally from the loads connected to the same dB, then it's not a requirement. So a few more questions really needed to resolve that one completely. But look at is there a double pole means of isolation. Another one that I think finished up last week. Again, we're just going to read it as it was left in the chat room, because this is one of those questions that got multiple questions wrapped into it. So, installed lots of external sockets recently without knowing what the customer is going to use them for. If they plug an electric car into a normal 13 amp socket to charge it, without the correct type of RCD for DC current. Is this okay? Do the car chargers have another protection to cap the DC current? So if we look at the first bit, if they plug an electric car into these outside sockets to charge it without the correct type of RCD for DC current, is this okay? So Mark, if we knowingly installed an outside socket without the correct type of RCD protection, we wouldn't be compliant, would we?
No, not necessarily. I mean, there's, as you say, there's quite a few facets or things to think about, isn't there, for this? So, because it depends on the size of the charging equipment as well. I mean, they're rated at either generally 16 amps or 32 amps, aren't they, for either long or short durations. So you could well overload a conventional, 13 amp socket outlet. But the question you asked about capping of the DC current, sorry, we haven't discussed that second part yet, have we? We're only on the first part. But I mean, is there sufficient capacity in the circuit to power that equipment as well? There is a potential for the charging equipment to generate DC currents or the vehicle, so you'd need to think about an appropriate RCD for that, wouldn't you? Because a standard AC RCD may well not work, almost certainly will not work, if you've got even small milliamp DC fault currents within the installation. So that could be a big problem. No,
it's and I think I know it's very difficult, but our general recommendation would always be you've got to have that conversation with a customer to determine what are those sockets going to be used for, and then you can best design and install what's required to give the client the functionality that they want, but also to ensure electrical safety for continued use. Because there's it opens up a whole raft of things, like if you're exporting a TNS or a TNCS earthing arrangement outside through your socket and you've got extraneous conductive parts outside, you don't want to give people simultaneous access to those two earthing arrangements. So it does open up a lot of questions, and it it's really important so that you can't be accused at a later date of not having provided what the customer wants. Make it quite clear. Ask them what they're going to use it for, and then you can design it. If they don't say that it's going to be used for car charging, then say what it is used for, and record that on your electrical installation certificate, so that if they change its use at a later date, you can't be held responsible for that, because that's not what it was designed to do. And the last part of that, do car chargers have another protection to cap the DC current?
No, I mean, not all of them do, and that's where you'll need to check with the specific manufacturer of that equipment. I mean, it's called an RDC-DD device, a residual direct current detecting device. Don't confuse that with RCD. But no, it's specific to the manufacturer, and it depends on, basically, I would say it depends on the cost of the equipment and what functionality it comes with. But the update to section 722 now allows for manufacturers' equipment to have all sorts of protection built into them to help comply with the requirements where you're charging equipment outside on a PME earthing system. So it's very much check with the manufacturer on that one.
Yeah, absolutely. So as far as we're aware, that there's certainly chargers that have got DC detecting equipment, but we don't believe they cap. They don't limit it. They might cause the protective device to operate under certain thresholds, so they can turn the supply off. But we don't believe that there's any out there that have got a means of limiting the amount of DC current, but it's quite possible. So always check with the manufacturer of the equipment what installation requirements they require. Okay, we'll take a look at some of the questions coming into the chat room tonight. So let's have a look on the first one. Okay, doing an EICR, ring continuity on the red and black. Oh, good old red and black. So ring continuity on the red and black, okay, but nothing on earths. What would we code this as? So common question mark. What other checks can we do?
It largely depends on whether you can actually ascertain an adequate earth at each socket outlet, because if you've got, particularly important with class 1 socket outlets, but if you can confirm an earth at each socket outlet, that could be the difference between a C2 and a C3. If you haven't got an adequate earth, that may well be the C2. Also consider if the circuit itself is RCD protected, because that in itself will limit the potential earth fault current to the level that the RCD will disconnect at.
Yeah.
It will see quite a high rise initially, but until the RCD detects it. But so if you can establish an earth at each socket outlet, and it's RCD protected, that could be the difference between your C2 and your C3. And
one other, so so check that you've got an earth at every socket outlet. Check that you can meet the ZS, whether it be a breaker or an RCD, and check the adiabatic equation, because now you've not got a ring of two 1.5 mil conductors. You've only got a single radial 1.5 mil conductor because of the break. So just do that last check as well, that under fault conditions your cable's still large enough to carry the fault current for the time it takes to protect us. Now those all mean that you're safe right now, but you've still always got a question. Well, why is the CPC broken? Is the conductor damaged? Is the twin and earth cable damaged? Is it loose somewhere? So there are some sort of visual inspections to think about as well. But yeah, if you can prove that you've got a CPC at each and every socket, you can prove that you can meet the ZS, and you can prove that it's large enough through the adiabatic equation, then it's actually safe for continued use, bearing in mind the principle of, okay, so how did it get damaged? So you might want to consider, we don't know how many sockets are there on it. Think about opening up, checking all the CPCs for tightness, having a look, has there been any work being done? Is the cable likely to have been damaged? In which case, the line and neutral might get damaged in the future too. So yeah, have a think about those. But yeah, it's a common question. We do get that quite a lot. Another one that's come in: can you clarify requirements for main equipotential bonding on a domestic new build? Main water, plastic pipe entering the property, and plastic pipe used inside. No bonding required. Yeah, well, yeah, I think we'd agree with that, wouldn't we?
Yep.
And then, so it went on to say main gas, plastic pipe entering the building, metal pipe from meter up into ground floor ceiling for boiler and cooker. Is a 10 mil bonding conductor required on the gas pipe? So if it's purely an internal gas pipe, so it's isolated metalwork which can't introduce a potential from outside because it's got no connection to the outside world, would we need to bond it, Mark?
No, I mean the reg says that you don't have to, and it says where there's a plastic insert close to the where the part enters the building, there's no requirement to put a bonding conductor on. There's only a requirement where that pipework is in contact with true earth, because then it's able to introduce a potential into the installation, which could be different to the potential that's inside that installation.
Yeah, I think. Sorry, Mark.
Sorry, I was just going to say, and it's the contact between the two parts that are at different potentials that cause us the issues.
Yeah. If you think about it, there's lots of isolated metalwork in a typical domestic house that, because it's metal, is conductive, but we don't need to bond it if it can't introduce. So if it doesn't come in from outside, it can't introduce a potential that's not already there. So no, if that copper pipework just goes from the internal meter up internally to the boiler and cooker, then there's no requirement, because it doesn't meet that regulation of being an extraneous conductive part. It only meets the regulation of being a conductive part. Okay, we've got another one. Can I use table 4D5 for other cables than twin and earth, such as SWA? Mark?
No, I mean, that table is specific for flat sheath twin and earth cables. For any other type of cable, you'd need to go to the manufacturer's data to see if that data is available effectively.
But you could. There are some others in Appendix 4, aren't there? So if you look at the beginning, you'll find multi-core PVC, and you will find an armoured version, which you can use for SWA. So just if we very quickly. So for SWA, you'd be looking at 4D4A. So that's multi-core armoured 70 degrees C thermoplastic insulated cables. So that's the one you'd use. So multiple current carrying capacity tables in Appendix 4. You just need to marry up the right table with the right type of cable. Another one that's popped in: kitchen down recessed lights has to be IP65. That sounds a bit onerous. What's your thoughts on that, Mark?
Yeah, I mean, the IP65 is generally going to be for areas where there's, lots of splashes of water, or, high sort of dust content, I would think, something like that, where you need to provide a high level of ingress, protection against foreign objects.
Yeah. I mean, that would almost be external, wouldn't it? 65. Let's just have a quick look.
60. We have got a pocket guide on that. I'm just looking through it myself. So
that's dust tight and protected against water jets. Yeah. No, that does sound a bit onerous. So the first thing would be to say that there's no specific requirement in 7671 for kitchens. They're not treated as a special location, in which case there's no specific IP rating quoted. So we would just be looking at general regs, which says it should be suitable for the environment. It's not normally a requirement to have such a tight IP rating for an internal, but having said that, you've just said it's a kitchen. I've read into that it's domestic. It might not be, so you might have some specific reasons, but yeah, it needs to be suitable for the environment. So it would be a bit of a risk analysis of what's the likelihood of solid object ingress and moisture and water ingress.
Well, it's worth mentioning, Sam, Pocket Guide 16, because that will give you the overview of the common IP rating codes. But yeah, as Sam says, I mean, there's not a requirement for IP65 equipment unless you can have a swimming pool in your kitchen or something like that. But there might be a requirement possibly under Part P for kitchens in Wales? I don't think there is, but as Sam says, as far as BS 7671 goes, it's not a requirement.
There's no specific requirement for associated with kitchens. Just the general that everything we install has to be suitable for the environment, or the way that we install it makes it suitable. So yeah. The engineer that's come back about the gas meter has said, thanks for answering the gas meter question. I thought it had to be fireproof. No, well, not BS 7671 doesn't drive us down that way anyway. Let's have a look. And we've also got underfloor heating under 13 amp fused connection unit from ring circuit. What code should this be? Well, there's nothing specific. So 13 amp. There's some guidance about overloading rings, and that's where I think we'd go with that. It does depend very much on what's the ring. The guidance is that we don't provide heating greater than 2 kilowatt on the basis that we might overload the leg of the ring that 2 kilowatt single load is connected to. So yeah, nothing specific just for it, just because it's underfloor heating, but it would be a loading issue. So you'd need to have a look at what else was on the ring, and if there is any information about, is that heating system time controlled, temperature controlled, what kind of likelihood is it to be on for long periods of time. We've got the engineer saying thanks for the PV answer, isolators installed, so all happy, only concern was RCBO. So yeah, the RCBO doesn't need to be dual pole, it just needs to provide overcurrent protection if RCD protection is not needed because of the cable run and the cable type selected. Okay, if you have a 400 amp buzz bar chamber, is it okay to fit cables rated under 400 amp onto the buzz bar if final circuit is less than 400 amp and unfused? So this is where we're tapping off a buzz bar that's got current carrying capacity of 400 amp and hopefully overcurrent protection at 400 amp, but the cables coming off obviously are much smaller. There's a specific reg that talks about this, isn't there, Mark? Because we've got distances involved. So what's the reg first of all?
There is, yeah. I was just trying to look for that quickly. It's where you can omit protection against overload, 433.3.1. So for a conductor situated on the load side of the point where a reduction occurs in the value of current capacity, where the conductor is effectively protected against overload by a protected device installed on the supply side of that point. There's basically three kind of conditions. I think the one we're looking for, and I may not have completed the right reg here, but bear with me. For a conductor, because of the characteristics of the load or supply, is not likely to carry overload current, provided that conductor is protected against fault current in accordance with the requirements of section 434. Yeah. So there's that one. It's the one directly above or at the top of that page, Mark, that talks about 433.2.2. Yeah. Sorry, apologies, folks. It's been a long day. Yeah, the device protection against a conductor against overload may be installed along the run of that conductor if part of the run between the point where a change occurs in cross-sectional area or method of installation or type of cable or conductor, and the position of the protected device has neither branch circuits nor outlets for connection of current using equipment and fulfills at least one of the following conditions. it is protected against fault current in accordance with the requirements stated in section 434, or its length does not exceed 3 meters and it's installed in such a manner so as to reduce the risk of fault to a minimum, and it is installed in such a manner to reduce to a minimum the risk of fire. So effectively, you keep your conductors short, no more than 3 meters, and you install it in such a way that they're not likely to become damaged. But it does also depend on the load on the end of those conductors.
Yeah.
That it shouldn't exceed the 400 amps further back.
Yeah. So let's say that, a typical example would be we might want to tap off that buzz bar chamber for 100 amp load, let's say a motor. So we can come with a cable that's capable of carrying just 100 amps, because we're going to protect it with an overload in the motor control center. So long as you said, that's a serial link directly from the buzz bar chamber tap off to the protective device, then that's perfectly adequate to provide overload protection for that smaller cable. We know it's not capable of carrying 400 amps, but it should never carry that because the load that it's supplying, and there's adequate overload protection to ensure that design current for the load will never be exceeded. So yeah, that's perfectly acceptable to do that. You don't have to rate everything at the current carrying capacity of the buzz bar and its overcurrent protective device. But yeah, have a look at, as Mark said, 433.2.2, and that's quite a common approach to use that cable that's suitable for the environment. So depending upon what your environment is, industrial, whatever, and a short run so that it's not likely to be damaged, you can physically see, and that means you can protect it adequately for the environment that you can see it in. Okay, we're rapidly running out of time again, so we'll fit a couple more in. TT system, 100 milliamp RCD before the main switch fuse, sub-main from switch fuse supplying a house. Can we have single pole Rcbos in the consumer unit? So this is the situation with so we've got two TT system, 100 milliamp RCD before the main switch fuse, sub main from the main switch fuse supplying the house. Can we have single pole Rcbos in the consumer unit? Yes, you can, for fault protection and additional protection where required. You would need to think about ensuring that your cable runs are as short as possible if you're relying on the fuse in the service head for protection of that. But yeah, so answering the question, can we have single pole Rcbos in the consumer unit? Yes, but you need to have a think about the distribution circuit feeding the board as well, in terms of its length, because you might need additional overcurrent protection for that side. Anything else you'd add to that, Mark?
I don't think so. So there would be RCD at the start of the circuit. Is that the distribution circuit?
Yeah, that sort of raises another one, because is that really required? So he said TT system, 100 milliamp RCD before the main switch fuse, right, and then a sub main from the switch fuse supplying the house. So yeah, I think it used to be almost the norm that people would put 100 milliamp RCD up front, but there are some options there, aren't there?
There is, yeah. I mean, it would to achieve full discrimination, it would need to be time delay, for example, on the 100 milliamp RCD. I mean, you don't have to use 100 milliamp RCD. You could go bigger than that to make sure that you're not going to get any nuisance tripping on your final circuits, and only the protected device on that dedicated final circuit will disconnect. that's probably because I have experienced sometimes with some time delayed versions that they can still disconnect when you're testing your devices at 100 milliamps, or if we're testing the 30 milliamp devices at 250 milliamps, for example, which we're allowed to do these days, aren't we, under the manufacturer's tolerances. You might still get the odd bit of nuisance tripping. So to sort of, protect against that completely, you could put a 300 milliamp device in, for example. I know that wasn't the question completely. The question was regarding separate 30 milliamp devices for final circuits, wasn't it? But
it's possible, because obviously that upfront RCD could create a single point of failure, and so if you can do something to minimize that or remove it completely, that's also a consideration. But yeah, in principle, on a TT installation, nothing wrong with RCBOs on all circuits. Obviously that they have to be rated such that they provide adequate fault protection and additional protection where required, but yeah, there's nothing that says you can't use single pole RCBOs. Way out of time again. We'll just finish it off with a good old standard one. Can I use flexible cables within a domestic installation and still be compliant with 7671?
You can. BS 7671 does allow for flexible cables, but they would normally have to be of the medium or heavy duty type, unless your method of installation can offer adequate impact protection to sort of medium duty cables, or they're installed in such a way as to, again, reduce the possibility of them becoming damaged. There's a
specific reg, isn't there? 521.9.1, and it's one of those weird ones, because quite often we get told what we've got to achieve without telling us how to do it. We don't often get told you can do this, and this is one of those rare occasions where it says flexible cable can be used. Well, it actually says shall be used for fixed wiring, it puts in a proviso, doesn't it? It only where, and then it's quite specific, isn't it, Mark?
It is. It's shall be used of the heavy duty type unless the risk of damage, which is during installation and service due to impact or other mechanical stresses, is low or has been minimised, or protection against mechanical damage is provided. So it's typically kind of, whenever we're running cables, it's sort of thinking about the environment, how we're going to install them, do we have to provide additional mechanical protection, or you use a heavy duty type such as your HO7s, RNFs, or your HO5s. I can't remember the last part of that one, but yeah, they were HO5s. Typically they're HO7s now that have got lots of abrasion resistance, and you've got to install them accordingly, taking account of zones and such like.
Yeah, I think that's the thing, that it's kind of recognised they haven't got the same mechanical protection as the sheath on the twin and earth cable, for example. So if it's suitable, and there are plenty of locations in a typical domestic where it would be suitable, but yeah, that's where it boils down to. That reg, although it says they can be used, it makes a point of saying providing the relevant parts of BS 7671 are met, and that would all be around it's not as hardware, and it's not got the same mechanical protection. And don't forget, it's not just in the location where it will be finally, it's your method of installation. So I always think, for example, of you drilling holes in joists and then pulling flex through. The sheath just hasn't got the same mechanical protection as you would get from Twin and Earth, for example. So it's not just is it suitable for the environment, but is it suitable for the method of installation that you've chosen as well.
Yeah, and there's a little note under that rig that gives you an actual British standard that you can check the versions of sort of medium and heavy duty cables. You know, the 50565-1. If you look at the table 1 in BS that gives you all of the British standards, it will give you perhaps a bit more information there. Appendix 1, I think it is.
Okay, well we've vastly overrun and run out of time again. We will, I promise you, we will do, because we've picked up a few questions there that we haven't got round to tonight. So we'll do the same again as last week. We'll roll them into the first part of next week's session. So thank you very much for posting the questions, and apologies if we haven't got round to answering yours this evening. But yeah, thank you very much. Just very quickly, there is a wire webinar this Wednesday. So if I just flash a quick advert about that up, it's another one in our EICR coding clinic series. So that's Wednesday the 14th of July, starting at 8 o'clock. If you haven't already registered, you can go on to the NICEIC website and register for that. That's something that you need to register for in advance, and then once registered, you can watch it live, or you can watch it on a callback as well. It will be available for roughly 12 months. So thanks very much. Thanks, Mark. Another whistle stop Monday night. I'm always amazed at how quickly they go. So thanks very much. Any last final words?
Not that I can think of off the top of my head. Just yeah, stay safe and yeah.
Well, we'll see you all next Monday. Yeah, keep the questions coming. It's always good, and thanks for the messages of thanks as well that come in. They're much appreciated. So yeah, keep asking the questions, and we'll keep doing our best to answer them. Thanks very much.